Alright, we're going to begin talking about slope and linear functions, and we're going to begin with giving ourselves a formula for finding the slope of any two given points. So the slope between 2 points. And we'll do a little review, hopefully from last year, just reminding ourselves what this slope means. What is slope? Slope is going to be the rate of change of a linear function, and it's going to be equal to the change in y over the change in x. You can think of that, oftentimes we think of it as a rise over run. And right, if we drew a picture, right, of like, let's say a ramp, maybe I'll draw 2 ramps to illustrate this better. So this orange ramp, I wanted to think about the slope of the ramp in like real life. How could I think about that? I could think about how much the ramp goes up, the rise, versus how far the ramp goes over, the run. And this, we put in a staircase when I was a little kid, and in carpentry, if you're designing stairs, cities have certain code for how, they don't want you to put in stairs like this in your house because people will fall down them. So there's a code for the rise and run. They're called, in carpentry, they're called risers and I think runners, something like that, basically. Yeah, I'm gonna say that's right. So this would be maybe have a bigger slope than this, because here I only go up a little bit. Maybe I'll write this as delta y, which stands for change in y over change in x. And we use y and x because in math, when we think of things visually, we like to think of them on this grid. And if I go up, that's going to be my change in y, because my y value of any one of these points is going up. Here my y value is, let's say 0, it looks like, and here, I don't know, maybe it's 5. And similarly, if I go over this way, my x value is changing. So this is going to be the formula we always fall back on, rise over run. So in the box below, we'll write a formula that will help us calculate the slope between 2 points on the coordinate plane, right? This is that coordinate plane. And most times when we write it down in an equation, once we figure out this number, we can in general represent it with the letter m. So we often think of slope represented by the letter m. And now let's actually talk about this formula. So I encourage you to pause the video if you don't have this stuff written down. But I am going to scroll down a little bit, and scroll down a little bit more just so I can do those examples too. So here I go. For any 2 points, my slope is going to be equal to, I'm going to use this formula, which comes from rise over run. And that's going to be change in y over change in x. And this is this symbol delta. And this means change in. So change in y, change in my vertical distance, and change in x. So when I'm given 2 points, and we're going to use these subscripts to distinguish the points from one another. So this would be the first point, because the x and y value have the subscript 1. And this would be the second point, because the subscript is 2, x2, y2. That's usually how we're going to say this. We just say x1, y1, and then x2, y2. And how do we figure out the distance between two numbers? We're going to subtract them. You usually do final minus initial. So we're going to take, if we want the change in y, I'm going to look at the y value of the final point, which is y2, and I'm going to subtract the y value of the first point, which is y1. So keep these colors the same, y1, y2, and then it's going to be over the change in the x value. So I take the final x value, x2, and I subtract the first one, x1. So a lot of times these subscripts are confusing to people, but we just want to remember that all it's saying is that, you know, this is 1 point. So the first point will have the subscript 1 on both the x and y value. And the second point gets the subscript 2, just so we can keep track of them for this general formula. Once we get an example, it's going to be pretty easy. So let's pause the video, write this down, and I want you to, once you have it written down, I want you to try example 1. And I'm going to assume that you paused the video and gave that a shot. If not, rewind, pause it, try it. All right, let's get going. So I'm going to follow this formula, but I can also just think, okay, first point, second point. So I need the y value of the second point, so 1, minus the y value of the first point. So that's going to be 3. See, this just means the second value listed. Okay, it's 3. This is the second value listed at the second point. It's 6. Y values. Oh, I didn't write this right. 6. Be careful that you choose the right value and don't make a mistake there. Okay. So go to green. So now I'm going to look for the x value. The second point is 1. So let's divide by 1 minus the x value of the first point, 4. What is that equal to? That's going to be equal to 6 minus 3 is 3, and 1 minus 4 is negative 3. You could leave it like this. Really, you should reduce this. 3 over 3 is 1. Because there's one negative sign, it's going to be negative. So I think the best way to learn this formula is to just use it on a bunch of examples. So I want you to pause the video and try example 2. All right, I'm going to assume you gave that a shot. So let's take the y value of our second point, which is 2, subtract the y value of our first point, which is also 2. And then I'm going to take my x value of the second point, which is 5, and I'm going to subtract the x value of the first point, which is 1. And what's going to happen here? 2 minus 2 is 0, and 5 minus 1 is 4. And think about what this is asking you. It's 0 divided by 4, which is 0. All right, let's scroll down here. I'm going to pause the video if you're still writing down this. Oh, we could actually, let's graph it. Yeah, we did this, yeah. So let's just look at where these points were. 4, 3, and 1, 6. So if I kind of drew a sort of a triangle, this is going down the ramp, so it makes sense that we have a negative. And it goes down 1 over 1, down 1 over 1, down 1 over 1. Our formula is working. Here, let's see, 1, 2, and 5, 2. Can't really draw a triangle here. Right? A slope of 0, that kind of makes sense that it's just flat, right? It's like the Midwest. You have no slope. Pretty flat out here. Alright, let's look at two more examples from the back page. So, oftentimes on tests or, just in the real world, if you're trying to find something, it might not be labeled. So oftentimes the points for us are not going to be labeled as x1, y1 or x2, y2. We have to make that designation ourselves. And it actually doesn't matter which point you choose as first or second. So I almost always just, whatever one is listed first, I'm going to call the first point. And whichever one is listed second, I'm going to call the second point. So maybe I'll just do 1 and 2. So that first point, second point. So if I want the y value of my second point, that would be -1. Then I need to subtract the y value of my first point, so 3. Then I need to take the x value of my second point, which is 5, and I need to subtract the x value of my first point, which is -3. Notice how I put that in parentheses. It's always kind of good to be very careful with negatives in this class, as we will find out. This is going to be equal to -1 minus 3 is -4, and 5 minus -3. Okay, wait a minute. Minus -3 is going to be positive. So this is going to be 5 plus 3, which is 8. Now, that's fine, but you should really reduce that to -1 over 2. And let's look at the points plotted, -3, 3, and 5, -1. So this is kind of my, oh, that's a terrible line. It's hard to draw on this tablet sometimes. Oh gosh, I'm just going to connect them. Right? This is saying if I want to interpret this as a rise over run, -1, so I'm going down 1 over 2. Down 1 over 2, down 1 over 2. And it works. Okay? I want you guys to try example 4 on your own, and we will talk about the remainder of notes maybe in class.